All right, as you can see from the screen on the top, we are going to be talking about rational expressions. And in math, whenever you hear the word rational, you should be thinking about fractions. And whenever you hear the word expressions, start thinking about variables. And so what we are talking about are fractions with variables. And I know fractions are already everybody's favorite thing, and now we're going to add variables to them, and we're going to make it even more fun. Woohoo! But before we bring in the variables, let's just look at working with fractions again real quick. Let's remind ourselves with multiplying. Let's just say I was going to do something like 25 over 8 times 12 over 5. And I could multiply straight across, but a lot of you guys know about cross-canceling. If you don't, basically what we do is think about common factors in the top and the bottom. So like 25 is 5 times 5, 8 is 2 times 2 times 2, 12 is 2 times 2 times 3, and of course we have 5. And now we do have common factors in the top and the bottom. Because we're multiplying, and the key is this only works with multiplying in the middle, because we are multiplying, and when you multiply fractions, you multiply the top and you multiply the bottom together. And so if I were to take this numerator and multiply it together, I get this. If I was to take this denominator and multiply it together, I get that. And now I have the giant 1 in there. So there's a 5 over 5, which is 1. There's a 2 over 2, which is 1. A 2 over 2, which is 1. And I'm just multiplying by a whole bunch of 1s. So I can take what's left. And in the numerator, 5 times 3 is 15. And in the denominator, I just have a 2. And the nice thing is, it's already simplified. Since I found all the common factors in the top and bottom, I have actually already simplified this thing. So, hooray! Now, a lot of times we don't show that work in the middle when we're cross-canceling. We can see common factors right now. There's a 5 goes into 25 5 times and into 5 once, and 4 goes into 8 twice and into 12 3 times. And so now if we multiply the top and the bottom, we still get 15 over 2. So yes, we could have taken that. But we're basically doing the same thing, and that's the key that I want you to know, is that we are looking for common factors in the top and the bottom and canceling them out when we are multiplying. So now we're going to take that same idea and apply it to rational expressions. So let's take a look at this example. Let's start off with r over r minus 1 times r squared minus 1 over r squared. Now you want to look for common factors. That's the key. So when we're dealing with rational expressions, you're going to want to fully factor the numerator and denominator first. That's what I did over here on this first example. I fully factored all the numerators and denominators. So I'm going to do that over here also. And really the only thing that factors further is this r squared minus 1, because it's difference of squares. So the first fraction won't change. It's r over r minus 1. But if I factor that using difference of squares, it's r minus 1, r plus 1 over r squared. Now that we've fully factored the top and the bottom, we can look for those common factors. And now we can see factors. R minus 1 is the same in the top and the bottom. And this r will cancel out with one of those r's. So in the numerator, I'm left with r plus 1. And in the denominator, I'm left with r. And so that looks like my answer. But I'm not boxing it yet, because there's something else. So this is the other difference with rational expressions. So one difference is we're going to fully factor first. We don't always have to write out the fully factoring with just numbers, but with rational expressions, you always want to fully factor first. But then we have to worry about something different, and that's because we got variables. What's the one value you can't have in the denominator of a fraction? And if you're thinking about 0, you would be correct. In the numerator, or in the original problem, think about what values make the denominators equal 0. In the first fraction, when r equals 1, that makes the denominator equal 0, so we don't want to be equal to 1. We can't be equal to 1. In the second fraction, 0 would make the denominator equals, 0 would make the denominator equal 0. So we also don't want r to equal 0. So these are our restrictions. We call these implicit restrictions at this point because we can still see in the original problem. We normally don't write this because it's clear from the original problem. We have an r minus 1 in the denominator, and we know 1 makes that 0. And we have an r in the denominator here, and we know that that would make this denominator equal 0. So we don't write this normally, but we know it to be true because we can look and see. Now look at the bottom. In order for this to truly be equivalent to this, it has to have the same exact restrictions, but it doesn't. I can look at this and clearly see that r can't equal 0. That's obvious. 0 is going to make that equal 0. But if I let r equal 1, which should have been a restriction, I'm going to get 2 over 1. It doesn't cause any problems here, but it did up here. So I have to explicitly say that r can't equal 1. This is called an explicit restriction. I'm not going to test you on, do you know the term explicit restriction? But it just basically means it's a value that the variable can't equal that's not obvious by looking at this. So in order for this final answer to be equivalent to what we started with, I have to include that explicit restriction of r can't equal 1. It actually wouldn't be wrong if you also included r can't equal 0. Oh, I just realized. Let me put a little can't equal to there. It wouldn't be wrong to include that in my final answer. I just don't need to. That's already implied. It's already implied r can't equal 0, so I don't have to state it explicitly. But it is not implied in this answer that r can't equal 1, so I have to explicitly let people know that. So that's the key. That's another big difference there. But otherwise, it's pretty straightforward. You fully factor the numerators and denominators, look for common factors in the top and the bottom, take what's left. Just don't forget about restrictions. Okay, so let's look at another one now. Let's do x plus 3 over x squared 3 minus x times x minus 3 over 5. So the first thing you do is take a look and see if anything factors. And in this case, actually nothing factors. It's already factored. So I could just go on now and start canceling. So I can definitely see that there is an x in the numerator that's going to cancel out with one of those in the denominator. And, well, that looks like it. I mean, yeah, I've got an x minus 3 and a 3 minus x. They're really close, but close is not quite enough. So let's take a look at what we have now. In the numerator, I have x plus 3, x minus 3 left. And in the denominator, if I rearrange things to put them in a more natural order, I've got the x and the 5. I'm going to say 5x in the front and then 3 minus x. So this is what I have so far. Except let's talk about this a little bit more. These guys right here, they are really, really close. But order does matter when you subtract, and so right now they're not exactly the same. So I can't cancel them right now. But there is a way to make these the same. Think about what you can do to make these the same. And if you were thinking about factoring out a negative, you are right. If in the numerator I factor out a negative from the 3 minus x, and I factor it out, so I'll put it in front, the negative x becomes a positive x, and the positive 3 becomes a negative 3, and now I have matching factors that will cancel. So before restrictions, I'll see what I have to list. This is my final answer. Now, just so you guys know, you can put that negative in the top or the bottom. If you put it in the top, just don't forget, you would have to put the negative out in front of the parentheses to show that it would be multiplying by the entire numerator. But whatever you do, do not put the negative in the top and the bottom. Because if you put it in the top and the bottom, they would just cancel out and become positive, and that's not what we want. So you can put the negative in the bottom, you can put it in the top. Doesn't matter. You can actually even just put it out in front. You could do this. This is harder though when you're handwriting it. You'd want to show that it's right out in front. So you want to be careful, because what happens sometimes when people handwrite it and just put it in front of the fraction is it looks like this. That negative sign starts to float up into the numerator. And now I don't know, are you talking about negative x plus 3? Is this what you wanted in the numerator? And then that wouldn't be right, because you'd need parentheses. So when you're handwriting, I wouldn't recommend it. When it's typed, you actually often see that. All right, so anyway, I'm going to get rid of all of this. Think about restrictions. So take a moment, pause the video actually, and think about what restrictions do we have to list. And if you were thinking that 3 is your restriction, you would be right. So in the original problem, we had a 3 minus x. X cannot equal 3. X would make that equal 0. But if x is 3 now, it's not going to cause a problem. So we have to include that as a restriction. 0 is still implied. There's still an x in the denominator. Another way of thinking about it is, if you have something in the denominator that is no longer in the denominator, you need a restriction. What makes that equal 0? We had an x in the denominator, but we still have an x in the denominator. I don't have to list 0 as a restriction, but I did have to list the 3. All right, I'm going to give you one to try, and I'm going to put this here, and then I want you to pause the video and try this one on your own. Now I'm going to put one little trick in here, and that trick is, I'm not going to make this a multiplication, I'm going to make this division. But think about what you do with fractions normally with division. What do you have to change them to first? So you would change it to multiplication and flip the second fraction and then just do it from there. So go ahead and pause the video, see how you do, and then I will reveal the solution. So pause the video right now and try it on your own. All right, so this is what you should have gotten. Now be careful about trying to do too much at once. I see a lot of students do it. It's just you're working so fast. Notice how I didn't do anything. I know I could have factored and flipped at the same time, but I see all the time mistakes, silly mistakes being made. So I would encourage you not to do that, especially in the beginning. But it would be okay if you did. But notice the first thing I didn't change the first fraction, changed it to multiplication, flipped the second one. Then I fully factored, and then there was a whole bunch of stuff that canceled out. And since I didn't have anything left in the numerator, that meant that there was a 1 left, a factor of a 1. The only thing left in the bottom was a 3, and I needed these explicit restrictions. So there you go. There's multiplying and dividing rational expressions in a nutshell. Okay, so let's take a look at adding and subtracting. So what does that look like? And adding and subtracting is just like before where you need a common denominator. Well, it's no different here. You need a common denominator. So let's just look at some examples, because you guys already know how to do this, because you know how to work with fractions. It's really the same thing. You just have to find that LCD. So let's look at this first example. 3 over x minus 1 minus 5. So just like before, if we have a whole number, you can think of that denominator as a 1. I know my LCD is going to have to be x minus 1. So I don't have to change the first fraction. That already has my LCD. But the second fraction, I'm going to have to multiply top and bottom by what's missing from my LCD. I needed an x minus 1 there, so I have to multiply top and bottom by that. So then I will have 3 over x minus 1 minus 5x minus 5 over x minus 1. Now that I have a common denominator, I can go ahead and combine the numerators together. So again, just like dealing with regular fractions, keep the bottom the same, but combine the top. Be careful when you're combining the top though. That negative sign, that minus sign, is going to distribute to the entire numerator. So it's going to distribute to this negative 5, and it's going to make it a plus 5. So my final answer is going to look like negative 5x plus 8 in the numerator and x minus 1 in the denominator. So just be careful. That's going to be a common mistake that's easy to make where you forget to distribute the negative. Do we need restrictions here? Think about that question. And the answer is no. I didn't lose anything out of the denominator. If you lose something out of the denominator, that's when you need restrictions. But I didn't. In my denominator, I had an x minus 1, and I still have an x minus 1, so I'm good. All right, let's take a look at another one, and then I'll give you a couple to try on your own. Get a new page here. All right, so try this one. Try 2 over x squared minus x minus 2 minus 10 over x squared plus 2x minus 8. So let's think about this one. I need a common denominator. Now, what you want to do when you find your LCD is you actually want to factor all your denominators first. I didn't have to worry about that with this previous example. My denominator was already factored. I couldn't do any more with that. But now I have a denominator that does factor. So actually, that's my first step. I got to factor that denominator. So the first one's going to factor into x minus 2, x plus 1. The second denominator will factor into x plus 4, x minus 2. So now I'm ready to find my LCD. Now my LCD, least, smallest, common, and then sometimes it's called a least common factor, or sorry, least common multiple. So it's got to be, think about it this way, it's the smallest thing that contains both denominators. I need an x minus 2, x plus 1. That's my first denominator. Start with the first denominator. Whatever that denominator looks like, that's definitely got to be part of your LCD. There's no question. Go to your next denominator. I had an x plus 4. That's not already in my LCD, so I need that. But there's an x minus 2, but I already got it, so I don't need it again. And sure enough, if I look, here's my first denominator, and then these two together make my second denominator. So both denominators are in there. It's the smallest thing that's in both denominators. So now I'm good to go. I have to multiply top and bottom of each fraction by whatever I need to make the LCD. And in the first fraction, that's going to bug me. That's a little better. In the first fraction, I don't have an x plus 4. So I need an x plus 4 in the top and the bottom. In the second fraction, I don't have an x plus 1. So I need to multiply the top and the bottom by x plus 1. Now the good news is you don't have to multiply all your denominators out. Leave your denominators factored. You have to multiply the numerators together, but not the denominators. So I'm going to have a common denominator already. I'm just going to go ahead and put this all over this common denominator because I know that's what's going to happen. My numerator in the first fraction was 2 times x plus 4, And the second one was minus 10 times x plus 1. And then I can just simplify that numerator. Distribute the 2, distribute the 10, and combine like terms in the numerator. So that combines to a negative 8x minus 2 over x minus 2, x plus 1, x plus 4. Now, some people might be wondering, do I have to factor that numerator? And the answer is only if the fraction's going to simplify, only if there's a common factor in the top and the bottom. If I factored out a negative 2 from the top, I'm going to write it, but then I'm going to erase it. If I factored out a negative 2 from the top, I would have 4x minus 1, or plus 1, but that wouldn't cancel out with any one of these. So you don't have to. You don't have to factor out the numerator. You can, though. It wouldn't be wrong. But I'm going to leave it like that. And restrictions. What restrictions do I need? If you were thinking none, you would be right. I didn't lose anything from the denominator again. It's all in there since I didn't cancel anything out. I had an x minus 2, an x plus 1, but that's still in there. I had an x plus 4x minus 2, but that's still in there, so no restrictions. Okay, so I'm going to give you two problems. I'm going to give you one, try on your own, and then I'll give you another one, try on your own. So, whoops, let's try this problem. Try 2x over x minus 5 minus 5 over 5 minus x. Give that one a try, and then I'll show you the solution. All right, so here was this one. This one, remember, to make a common denominator, all we had to do was factor out a negative from here. That would give me x minus 5, but if I factor out the negative, I can do minus a negative and make it plus. And then this turned out to be really easy. Combine the numerators, keep the denominator the same, no restrictions. Woohoo! Alright, let's try another one. You guys try this one on your own. What was my next one? Try 2 over x plus 1 plus 2 over x minus 1 minus 1 over x squared minus 1. So give that one a go and see how you do. All right, so this is what you should have gotten here. One thing that I do want to point out is, because I see this happen all the time, and this has to do with how you show your work. These do get kind of long to write, and I was like, oh man, I know what the numerator is going to be. It's just going to stay the same. You know, I'm just going to leave that out. I'll put it back in the final answer. Don't do that. First of all, that's mathematically invalid. Don't do that. To write it that way, like if I just leave off all these denominators, I'm just going to go ahead, and I know I'm going to put it in later. If you're going to show your work like this, I'm going to take off points. Mathematically speaking, the next line should be equivalent to the line above it, and if it isn't, you need to put descriptions of why it isn't. In this case, there's no reason to leave off that denominator, except you're just too lazy to write it. So it has to be there. So make sure that you keep those denominators. But anyway, this should be your answer. Again, no restrictions because nothing got left off the denominator. All right, so we've multiplied, divided, added, and subtract fractions. What more could there be? Well, what if we had fractions inside fractions? Doesn't that sound like fun? Oh my goodness. So those are called complex fractions. So for instance, if I had something like this, x minus 4 over x over 4 minus 4 over x. Fractions within fractions. Now there's different ways you can do this, and honestly it does depend on the complexity of the problem. But in general, there is one way that is often the friendliest to do, so I'm just going to stick with that one. And that is, look at the denominators of the small fractions, the fractions inside the big fraction, and find the LCD of those. So the LCD then is going to be 4x. You're going to multiply the big fraction by that LCD. And let's take a look at what happens when you do that. So in the numerator, we're going to have 4x times x minus 4. But in the denominator, that 4x is going to distribute to both fractions. So we're going to have x over 4 times 4x, and then 4 over x times 4x. And by multiplying by the LCD, we're going to have some stuff cancel. These 4's will cancel, and these x's will cancel. And so what I'm left with, the numerator, I still have 4x times x minus 4. But in the denominator, I have x times x left, and 4 times 4 left. And so I got rid of the complex fraction. And so that's the key. Find the LCD of your smaller fractions, and then multiply the top and bottom of the big fraction by that LCD. Now some of you guys may be noticing this, I'm not done with this problem, because now I have to see if this simplifies. And I do have a common factor. I have difference of squares on the bottom. I'm going to have x minus 4. That cancels out. So now, in my final answer, I have 4x on the top and x plus 4. Think about restrictions. What restrictions do we need? I'll give you a hint. There's actually 2 restrictions I need to list. Can you see what they are? They are 0 and 4. Right here, that guy right there, I had an x in the denominator that's no longer in the denominator. So that's where that 0 is coming from. But I also, at one point, wound up with an x minus 4 in the problem, or in the denominator in the problem, but it's no longer there. I need to include that as well. So I actually had 2 restrictions here, whoops, and then I have my final answer. So again, the idea with complex fractions, factor the denominators if you can first, but then find the LCD and multiply top and bottom of the big fraction by that LCD. All right, I'm going to give you guys one to try, and we'll take a look at the answer together. So try this one, a little more complicated looking, but same idea. X plus h over x plus h plus 1, that's an h, minus x over x plus 1, all over h. Sometimes this is called the difference quotient, because it's a difference, subtraction, in a big fraction quotient. These difference quotients you work a lot with in calculus. So, all right, so give that one a shot. Try simplifying it, and simplifying it. Get rid of the complex fraction. Simplify it fully. We'll see where we go. All right, let's take a look at this. So this is what you should have gotten. Oh my God, there's so much stuff going on here. So my denominators don't factor at all. This doesn't factor. This doesn't factor. But they're not exactly the same factors either, so I need both factors in my LCD. Now remember, that is going to distribute to your numerator. So when this LCD distributes to the first fraction, the x plus h plus 1's cancel, but I still have an x plus h, and I still have an x plus 1. And then in the second fraction, the x plus 1's would cancel, but I still have an x, and I still have an x plus h plus 1. And then when I multiply the LCD by the denominator, nothing cancels out, so I have the whole thing. I have all of it. Then I'm going to see if this simplifies it all. So because of this minus sign here, I don't really have the numerator factored out. Instead, what I'm going to have to do is multiply this term, multiply out this term, combine like terms, and then see if it factors. So I multiplied these two together. And here, let me color code it. So I multiplied these two together, and that gave me all of this. And then I multiplied these two factors together, and that gave me this. But then I have a lot of stuff that cancels out. The x squared minus x squared canceled, the x minus x canceled, the xh minus xh canceled. All I was left with was the h. And then this h can cancel out with that one, and there's my final answer. And in this case, I did lose something out of the denominator, so I had to list that. And there we go. There's my restrictions. So there's my final answer there. Whew. So that's fractions in a nutshell. I do have a couple extra things, just something a little extra about factoring that's going to show up in your homework tonight. But there's fractions in a nutshell. All right, let's just take a look real quick at factoring. Go to a new page here. If I had something like this and I say 4x cubed times 2x minus 1 to the 3/2 power minus 2x times 2x minus 1 to the negative 1/2. Well, how do I factor this? Well, there's definitely a 2x. I think about what your greatest common factor is. Let me write that over here. We have two terms. Remember, terms are separated by plus or minus signs, not in parentheses. So these are my two terms. So in each term, I have a 2x. But there's also a 2x minus 1. It's just, what power do I factor out with? And you always factor out with a smaller exponent. Negative 1/2 is a smaller exponent, so that's what I'm going to factor out. So that's my greatest common factor that comes out. Now let's take a look at what we're left with. Once I factor that out, remember factoring is just dividing out. So when I have 4x cubed and I divide out a 2x, I factor out a 2x, I'm going to be left with 2x squared. And then when I divide, I'm going to end up subtracting the fraction. So what's 3/2 minus negative 1/2? That's going to be 4/2, which is 2. Let's try it again for the next term. I had a 2x, but I divided it out, so I'm not even going to have that anymore. And I had a 2x minus 1 to the negative 1/2. I divided all of that out. In this case, I just have a 1 left. So you can always test that by distributing. If I multiplied this by both of my terms, I would wind up with what I had. 2x times 2x squared is 4x cubed. And when you multiply with the same base, you end up adding the exponents, and negative 1/2 plus 2 is 3/2. It works. And then you multiply this by a 1, and you get that. But now I have to simplify what's in the parentheses, or the brackets in this case. Whoops. So I'm going to have 2x. I still have my GCF. That's not going to change now. Leave that as brackets right now. I'm going to have to FOIL out the 2x minus 1 squared. So it's going to be 4x squared minus 4x plus 1. And then I will distribute the 2x squared and get, whoops, 8x cubed minus 8. No, I won't. Let's do that over again. I'm going to have 8x to the 4th minus 8x cubed plus 2x squared minus 1. And we're going to leave it like this for now. We may be able to factor what's in that parentheses, but we don't know it at this point. Some of you guys may have seen it in other places called what do you call it? Synthetic division. But we're not going to do that until later this year. So there's your answer right there, factoring. So again, factor out with the smallest denominator. So let me give you guys smallest exponent, my bad. Factor out using the smallest exponent. Any of you guys want to try on your own, and this will be the last problem. So try 2x times x minus 5 to the negative 3rd minus 4x squared times x minus 5 to the negative 4th. See what you get, and we'll check your answers. All right, so here it is. Again, looking at that smallest exponent, obviously there's a 2x in both of them that can come out. And there's an x minus 5 to some power, and negative 4 is the smaller power, so that comes out. So there's my greatest common factor out in front. When I factor it out from here, the 2x is fully factored out, so I don't have anything. I have a 1, you can think of it as a 1. And then use subtraction. Negative 3 minus negative 4 is a 1. And then over here, if I have a 4x squared, factor out a 2x, I have a 2x left, and I factored out all of this x minus 5 to the negative 4th. Combine your like terms, and in this case, because there's a negative in front, I got to factor out the negative too, and I wind up with that. So there it is. There are your notes in a nutshell. All right, see you later. Bye.